Okay, we'll start our lecture today. Okay, so today it is 16, November 16th, so it's a week 11. It's week 11. So week 11 should be around here. Week 11. And today our lecture is a PCA. Okay. So because I spent one hour for the rest of the lectures for the deep learning. So I think that the progress is fine so far. Okay, so we finished our exam, the first exam. Okay, and the grade already announced on the Moodle or our course website. So you can check your grade, and next week we'll return your grade sheet, your grade sheet to you, your answer sheet to you。就下礼拜把那个答案卷发回去给他们，答案卷而已。两门课都要发答案卷回去。We'll talk about PC. Just about machine learning. So for the computer vision, talk about camera model, camera calibration, and we talk about the detection of descriptor called feature extraction, it's convolution. And then we have background modeling for motion detection. And we talk about detection and talk about tracking. And right now we start talking about recognition. So recognition, we apply the machine learning for recognition. And also we apply the deep learning for detection and recognition. But deep learning can do 3D reconstruction. Deep learning also can do the tracking. Talk about the PCA. Okay, PCA is very important for machine learning. It's amazing. It's a factorization. 它是一个因式分解的东西 It's a factorization. It's an amazing tool. The application is very wide. So I introduce the principal component analysis. And right now we use the GA. The PCA, okay, let's talk about the most important thing for the PCA application two issues. One is for the face recognition. Face recognition. Even though right now some face recognition is using the deep learning, but they embed PCA inside the deep learning. It's very important. In the deep learning network, they have a PCA inside. So this first one. Second one is again GAN. GAN actually is a developed based on the PCA. So it's two issues. So this lecture I'll teach you is unsupervised learning. So for the exam, the final, we have one more exam. So for the final exam, I will ask you, PCA is a supervised learning or unsupervised learning? The answer is PCA is unsupervised learning. It's for dimensionality reduction. But why? What is the unsupervised learning? Lecture. Actually, I updated the lecture in your FTP site. But you can, the TA can update it from the Moodle. I update this one. Here. Okay. So for the machine learning or deep learning, the learning thing, usually we have supervised learning. Zoom in more. We have unsupervised learning, semi-supervised learning, and reinforcement learning. So we have the basics of 4 kinds of learning. So what is the supervised learning? It's meaning you need to do the labeling. For the training data, you need to do the labeling. Okay. So for the result of learning, compare 4 of them. Supervised learning has the best result because we label each training data. Okay, but it costs of time. It's inconvenience. So it's problems to label the data because you need to use manually to label it. So the other thing important is how can you develop the labeling tool? So labeling tool is also important. Okay. So for the Google, they do the auto drive or something like that. Okay, or Tesla, they do Google do the map for the street, or the Tesla, they do the pilot, they do the automatic driver car or driving car. They have like 2,000 people that do the labeling, but they need to develop a labeling tool. But sometimes the labeling tool using the deep learning. For example, like when we do my lab, we do the non-nodule detection, and we develop a tool for data to manually label the nodule, like a segmentation. So in the beginning, they manually segment the nodule for the foreground, background, and later we have some data, and we use the graph cut. So it's just point a point, and then they automatically do the labeling, do the segmentation. So we call semi-automatic 的半自动方式。So you just manually click and then automate to do the segmentation for 2D. And later on we do 3D. Just click at one point and then label X, Y direction, label the Z direction for labeling. Okay. So that's a supervised learning. And next one is unsupervised learning. Unsupervised learning meaning you don't need to do the labeling. You collect the data. Okay. And they use the machine learning or the deep learning method. For the machine learning, the example is one the vector quantization for clustering. The other is PCA. I will teach you right now. Okay. And that's meaning you have data based on the vector quantization or PCA, they do clustering. But you don't know which class belong to what kind of we say each cluster you don't know belong to which class. You do the vector quantization or you do the PCA, they do the clustering. But after cluster, suppose you cluster to 5 clusters, but each cluster you don't know belong to which class. Or suppose we collect the data, they have a phase, they have a non-phase. You use the VQ, and it automatically to do the clustering. So one cluster is a phase, the other cluster is non-phase. But computer doesn't know that. They just know, okay, I have a classification, a class to 2 clusters. And then so after you do the unsupervised learning, and then you manually to do, okay, the first cluster belong to class 1, the second cluster belong to the second class. You just manually assign. So that's the unsupervised learning. So for the unsupervised learning, the result compared with the supervised learning is not good, but it's convenience. Okay. So what people try to improve, we call semi-supervised. So semi-supervised is a better method for the learning. That's meaning you just collect a small data, small part of data. Suppose I have 1 million data. We always talk about big data. Okay, so suppose you have 1 million samples and just pick up like a 10K, you want 10K samples, and you do the manually clustering. After that one, your training will based on, first of all, based on this 10K samples, and you do the training, and then you do the classification and try to expand to the unlabeled data. So finally, you can get a result. Okay. So semi-supervised is a good method for the big data. Okay, but the result is the supervised learning is the best. Semi-supervised learning is second, and unsupervised learning is okay. But right now, the deep learning try to improve what? Improve unsupervised learning and the semi-supervised learning, and they have a better result. So recent 2 or 3 years, okay, the deep learning people in the deep learning, they try to use the new method to do the improving of the semi-supervised or unsupervised learning. The amazing thing is that the result is good. But still, supervised learning has the best result, but it's no good or almost impossible for the big data. We talk about big data, probably million data. But right now it's very easy. We easy to have a million data. 对，这你要注意一下，最近3年这2个发展非常迅速，非常非常迅速，因为已经成熟了，这样子，在 deep learning 这个领域，那 people 已经往这边走了，那这2个都有，不是只有 semi supervised，是这2个都有在做，那结果是很好，那2个都一起就发展的很好，为什么？因为这2个互相影响，这个 level 就有了，那你这个改善，这个就改善。那这2个改善，这个就改善，所以最近这几年，大家往这边走。Okay, and the other one is we call self-supervised learning. What's self-supervised learning? It's meaning you don't need, actually, you just collect one data. It's like the GAN game. You collect data and try to do a classification. But at the meantime, you do the game. You try to encoder, decoder, and the result, the ground truth will be the same as your input data. So self-supervised learning is meaning based on the data you have. Okay. But it doesn't need to, it belongs to their body because it's the data you know. And you try to apply to big data. But you have this kind of constraint based on the the data collection. 就这个 self-supervised 也目前也一直在改善。那它好处就是你不用做太多 labeling。那重点是你把输入要把它转化成输出这样子。这个你们遇到再讲。好，那这个通常是比较少人，就比较少人在做这个，但这个也是很重要。那 finally is oh sorry, I have this one. So you compare supervised, unsupervised, semi-supervised, you'll see the accuracy, this is high. Okay, but this is I copied from the internet. Okay, and actually the semi-supervised is second, and unsupervised is third. Okay, and this for the learning, we have a supervised, unsupervised, and semi-supervised. And one more thing is that reinforced learning, reinforcement learning is also very important. Okay. Especially for what? Especially for like we do the robot arm, we do the automated mobile driving, 就是 AMR or 那个自驾车那些东西，都会用到 reinforced learning. And reinforced learning, the most important one we call, I think that here. Okay, so this one, this reinforced learning. It's meaning you take an image here, we call observation or call state. Your model we call agent. So that's meaning you create a data. For example, for the robot arm, I want to pick up an object. I want to pick it up. I take a photo. I did not tell the computer. Just give the photo to the computer. But I did not tell the computer what I say is we have a target. We have a target inside the view. And we hope the robot arm can pick up the target. Okay. So inside this one, robot arm just randomly pick up one. So pick up one is action, we call action. So suppose for the robot arm, the actions, suppose, is 4 directions. From front, go forward, backward, left and right. So have down and the top. So it's 6 action. So they move and they pick up nothing. So this meaning interaction. The robot arm interact with this environment. So we call environment. And then they do pick it up, grasp. And if they grasp the target, we give a reward 1. If the robot get nothing, the reward will be 0. So suppose in the beginning, you just give the image and robot randomly picks it. And then the reward, they get nothing. So they will record this reward is 0. And then take the second photo, second image. If they can pick the object up, then reward will be 1. So the computer will know, oh, okay, you want me to pick up the target. But they're based on the view, 2D image. However, the robot arm is 3D things. We don't do any calibration. We have a camera calibration. No, they don't do anything. They just give an image to the computer and robot arm to the grasp. Okay. And so if they can get a target, we will be 1. So next one, after they pick out the object, and then we move any object, we put a different position in the view. And they start to pick it up. And when it hit the target, and we'll record it, oh, okay, in this view, the target is here, and I should move. The path we call trajectory, the path, 路径。你有6个路径嘛？前后左右上下，它就去移动，抓到，要去记起来了。And finally, probably they train 100,000 times 10万次，他就看到就可以抓得到了。在影像看到 target 就可以抓得到。So the reinforced learning, we have the input image. We have algorithm, the modeling. It's learning. The learning. Using reinforced learning algorithm to learn the parameters, and then do the action. and then they got a reward, either 1 or 0. So this application right now is very powerful for the internet 的 game。就这个 RL 目前用的最广就是 game。Why? So when you have a trajectory, 你有路径的话，你就可以想 think about you have a trajectory. RL is a good method to find the best trajectory. We call shortest path, shortest 最短路径 path. So for example, we do the game, okay, in the internet. So computer play with you, and when the game they go like 那个超级玛丽吧，是不是？就 go 这样跳。If you go the path, okay, any second they record it. Oh, the path, so reward will be 1. The path reward will be 1 until suppose this view in the sometime the t they fail. 它失败了 and reward will be 0. That's meaning, oh no, you cannot go this way. So you start again, play with the game. So you just let computer to play the game by itself. So you keep playing. Actually, this is kind of what we call simulation. Not real, simulation. So sim to real, we call digital twin. 数位孪生的 digital twin, you have a simulation. And actually, like what I say is, we have a 10, you have a 10,000 times hit a target. You can do the simulation. Because simulation, you can speed it up. You can quite now simulate. When you simulate like a 90,000 times, 你 simulate 9万次，那你只要让它玩1万次 ，in real, just 10,000 times, and they will learn it. So the same again, they play with you. He can play by himself, and they will learn by itself. Okay. And if the game is 2 person, okay, you and me, you and computer. And first time they lose, but they remember. Second time they lose because they have 2 paths. Once you pass, what do you think? The other is the computer, his path. They interact with each other. So finally, because he's not only play with you, probably in the internet, they play with 1,000 people. And then each time they can learn from the path from the 1,000 people. So they're getting smarter. And finally, you are losing. Okay. So the game coming, okay. After they play 1, they will do the level. Okay, the level is meaning, okay, the level 0 is meaning that's so. Level 1 is better. Level 10 is much better. Level 5 is much better. And probably level 7 up more than level 7 will be professional 1. 所以它是把它分等级的，然后就开始跟你玩，让你去选你要跟哪一个等级的电脑玩这样子。好 ，OK， 所以这是 RL。So back to here. So PCA is unsupervised learning. The other thing is they can do dimensionality reduction. What's dimensional reduction? It's meaning if I recognize your face, suppose this face is 20 by 20 pixel. Sorry, detection between face and non-face is 20 by 20 pixel. So each time when I do the comparison, the input data is a 400 dimension, your vector, right? 20 by 20, so it will be 400 dimension vector. So if I compare you and the data of detection, the comparison is a 400 dimension by 400 dimension. But you can use PCA. Probably they can extract your information and then only use 10 dimension. They can do the same comparison and get the same result. So PCA can do dimension the dimensionality reduction. 它可以把大量的空间。So for the other examples, because right now our image is probably 2K by 2K. So the vector is very big. So when you do the comparison, okay, it takes time. So if I use PCA to reduce, probably only 100 dimension from 2K by 2K, and each comparison only 100 dimension. So that's called dimensionality reduction. Okay. And PCA is a fundamental thing for the machine learning. Okay. So when I teach you PCA, I will also teach you what's the domain knowledge. Domain knowledge. Okay. And then we have a PCA. So PCA is a Gaussian model. The other is ICA. So any data can separate to PCA and ICA. ICA is non-Gaussian model. And then noise. What I mean is that any data can classify to PCA plus ICA plus noise. And your data can use PCA, you can use ICA, and you delete the noise. And PCA also related to the covariance matrix. And PCA, one important thing is factorization is the supportive and singular value decomposition. I will teach you very soon about this one. Okay, so this lecture I'll teach you all of them. And before we talk about PCA, because PCA is a Gaussian model, and PCA is a domain knowledge space. So space transform. Actually, space transform. We have right now. I teach you R5 perspective, but for the transformation, usually is R5, and R5 can do geometric transformation. Geometry is meaning your map, your image. You can do translation, rotation, scaling. R5 also can apply to illumination, 光线的 normalization. 光线 can do translation, rotation, and scaling. For example, is this one. Any image you want to normalize the image, you can try to subtract with the mean value divided by standard deviation. So they have a translation. They have a scaling. How about rotation? Actually, rotation is a phase, 那个频率的东西哈，这里就不讲了。Okay. And then affine transform can transfer from the absolute relation to related relation. 它可以把绝对关系变成相对关系来做比较，那就Gaussian model。这是当然提供你参考。好，那我讲 domain knowledge， 那我后面就开始就先跳过去了，直接讲 PC 的东西。那个 dimensional reduction 有这么多工具哦。For the dimensionality reduction, they have many kind of tool: PCA, LDA, LLE, isomap, the plusing. All of them are for the dimensionality reduction. 那我开始讲 P. So PCA also called Hotelling transform, also called KL transform. Sometimes people call KL transform. And what's the principal component? PAL. The principal component is eigenvector, major eigenvector. So why we need PCA? Because PCA can do dimensionality reduction. Dimensional reduction. It's kind of a descriptor. So for example, like I have 1 million data. The image size is 100 by 100. So when I do the comparison, detection, tracking, recognition, for the comparison, for each image, I need computation for dimension 100 by 100. So after PCA, probably I can reduce the dimension from 100 by 102 supports only 50 dimension. And then I do detection, tracking, recognition. Okay. So PCA can reduce the computational time, can save the storage space. PCA also can apply to reconstruction as GAN. So PCA was related to what? Related to covariance matrix. So suppose if what I say, we have 1 million data, each image has a 10 and 100 by 100. So we call this one is A. And for the A, or actually I can say A times A, because A is not covariance, A is just a matrix. So suppose here I suppose so I say wrong. This should be C. And C times C will be A here. So it's a covariance matrix. And then I subtract with the mean value, and then I do the SVD become UWVT. So U will be eigenvector, W eigenvalue, V will be rotation matrix. So it's a Gaussian. So I say it's here. So this affine transform, UWVT. So I start talk about what's powerful for PCA. How can I reduce the dimension? So the concept is this one. First of all, suppose I have 3 points. The data has 3 points. I want to separate the 3 points. Suppose three persons. 1, 2, 3, 3 persons. How can you recognize these 3 persons? So if I project to the x-axis, you'll find this point, the sample, close with this one, but far away from this one. Far away is good because we can do the separation. 就越远当然越好，因为我要辨识人嘛。在空间中 ，in the space, we want to do discrimination. In the space, we want to do discrimination. Discrimination is meaning the classification. So we hope those sample can transfer to new space, and the new space will allow those points separated. So we want to do the space transform. It's called domain knowledge. 你要把你的 data 转到另外空间，那你希望这些 data 在这空间彼此分得越开越好，才有办法做分类。Remember, PCA is not for the simulated measure. They just do the space transform. PCA 本身，记得 PCA 本身它没有做量测哦，它没有做量测是方法，就是像说用那个 L1 量测，就是两个相减嘛 ，SAD 或是mean square difference， 那是量测的方法。For simulated measure, the methods, for example, is L1, L2. L1 is a sum of absolute difference. L2 is sum of square difference. You are just 2 methods. But PCA, no. PCA is first of all, try to transfer to the new space that each sample be separated. 让空间分得越开越好。This is the same as deep learning, right? Deep learning, we just talk about deep learning for each node. Feature map is 1 dimension. So the same is here. So how can I transform the space from XY to new space? And this new space will let each point be separated. So only actually 2 methods. Only 2 methods. One is from low dimension. So suppose this is only 2 dimension XY. I project to the high dimension. Using what? Using kernel function. What's kernel function? Activation function. So from the low dimension to the high dimension. The famous one we call supported vector machine, SVM. So SVM is that the new space from the original space to high space using kernel function. So it's the same as deep learning kernel function. Kernel function is an activation function. That's one funny. But this will cause a lot of computation because you need to have a higher space. So the second method is that from the space, we project to the low dimension. That's PCA. So PCA is from the original space. Suppose 2D, X, Y. I want to reduce to be only 1D, and then I do the classification. Okay. So if how can I do that? So if this 2D, each point is the XY is 2D. So if I project to the only x-axis, there is 1, 2, 3. 3 points is only 3. Only each one is 1 dimension. But this is separate. Both are closer. So, but the other way, if I project to the y-axis, y-zone, and then you'll find both are closer, and both with this one is separate. And the question is that any dimension, any axis can let those 3 points be separated. So that's this axis. If I can find this axis, you will find the 3 points will be separated. 就是说，我刚刚讲的，我们在做空间转换，就是有2个方式，一个是投影到高纬度，一个投影到低纬度，这2方式都可以。那投影到高纬度就是最有名的 SVM 嘛，刚刚提到的。那个 deep learning 就是用这个方式 ，deep learning 是高纬度哦。那 activation function 嘛 ，kernel function。那 PCA 是投影到低纬度，它降纬度了。那我们这个主题是要讲降纬度的。降纬度就是我刚刚讲的，运算时间减少，储存空间减少。那这里问题来了，那在哪个纬度可以让这些 sample 每个人的距离都推得很远？因为推得越远，最容易分辨嘛。大家聚在一起就不容易分辨了。我们3个人，你投影到 x 轴，我们2个相近，另外一个可以分出来。我们投影到 y 轴，这2个相近，那这个又困，这2个相近就是不容易区分。那我要投影到哪一个 dimension， 让这3个给做的就分得越开。So this is eigenvector 1. Eigen. So eigenvector 1 can separate each point mostly. It's called principal axis, 主要的轴. And then if eigenvector 1 you cannot separate, you can use eigenvector 2 and eigenvector 3 if they have high dimension. Okay, so that's why we need PCA. So the other example is one. Suppose we have more points, and which if they project all the points, they project to x1, they're not good. x2 is not good enough. So if I use PCA, I can find the eigenvector 1, this one. And all the points project to eigenvector 1. And most of them, the distance between each other is longer. But it's not enough, so I project to the second eigenvector 2. And then some of them can be separate. 就是说，我现在如果直接在 x1、x2 这个原始的轴来做分辨的话，这个很多很聚集。那我事实上透过 PCA， 它可以找到 eigenvector 1， 它可以找到 eigenvector 2， 这2个轴可以让我的这些点 sample 的点都分得很开，那我就可以做分类的用。所以 PCA 就是让你要找到一个空间，这个空间呢可以让这个 sample 里面所有的点都分得很开。这 PCA 就刚刚讲这个例子， 我的投影这个轴找到，我这3点就分得很开，我就很容易做辨识。这个一样，这个主轴就是 eigenvector 1，这个主轴另外一个主轴 eigenvector 2，这样子。所以 TCA the answer TCA can create eigenvectors, can create eigenvalue, and eigenvalue is a distribution of a standard deviation. Okay, so it's Gaussian model, and in the PCA space, it's can let people to do what? To do the face recognition, to do the face detection. So this application. So suppose we have the tool here, okay, the toy here, and we have this MIT tool, okay, they have a light here and a camera here, and we can rotate this one. And the purpose is here. The purpose is suppose I have 4 objects, the 4个物体. And how can you detect it? Using 多巴胺，你用多巴胺去抓。但是这4个物体是随便放在你的 view 里面，会有角度不一样的问题啊。这个每个角度不一样，拍起来看的不一样。那你怎么做这件事情 ？So we use this one. So suppose we take it for each object, we take this 9 by 5, 45. They rotate 360 degrees. So they rotate. They took 45 images. So we have 4 targets. Each has 45 images. And then if I put one target, one object there, can you recognize this object belong to which one? 就你现在有这个4个物体在空间，那你把它收集资料以后，随便给你其中一个物体，你知道这个物体是属于哪一个吗？ Because the pose is pose, right? So you need to rotate 360 degrees, like this one. So when you do the comparison, you need to compare how many times. So each time if I take one image, you need to compare this 45 times 4 times. 你要比你45次乘4个 object， 你要比那么多次。那每个 dimension 你要比的时候是要比这好像218吧？就 dimension 你要这样每个 dimension 都要去比。对不起，这是一个 vector 嘛，2D vector， 2D 的 matrix 那边 1D vector， 然后你去比，那你总要比45乘4次，才知道属于哪个是最小值嘛。所以 take time. Okay. So the other what I try to let you know is that we call manifold, also called domain knowledge. What's manifold? What's domain knowledge? It's meaning if this is a target and we have a 45 rotate. What's the physical property for this target? 就它物理性质是什么 ？What is its physical property for this target? You have a 45 rotation angle. So how can you represent in the space, 3D space? Because we can replace only 3D. So 3D space 就是说你一个物体给你，这个物体在空间中它的分布状况、分布图是什么？那基本上就这个图。Then you'll find you have 4 targets. Each object in the space, their curve, we call manifold, is different. So if any new target come in, okay, you'll find if the manifold is very similar to one of them, one of 4, they belong to the same target. 就是说，你怎么让一个物体在空间中表示 它的物理性质，那这就称为 manifold。那怎么做 ？You need to use PCA. So there will be the three axes will be eigenvector 1, eigenvector 2, eigenvector 3. I will teach you this one. OK， 再继续。那这里也是要跟你讲就是我这里要跟你讲这件事情，这里 this one。What is this one? It's meaning we have this one 45 for each target. We have 45 images, and I have 4 targets, 4 objects. So here, so if I combine 45 image times 4, so I do that here. I sum of them together. This is a linear combination. So we have an m. What's the m? M is equal to 45 times 4. 4 objects. 4 objects. So this 45 times 4 here. Equal to what? Eigenvector and eigenvalue. 就是说空间转换. So this original space. And then transfer to eigenspace become this one. 我再讲一遍哈。I always talk about linear combination is a basis function. This is important. Like a Fourier transform, cosine and sine. Cosine and sine. So basis function is a cosine and the sine. So any signal in the world can do linear combination by cosine and the sine. Cosine is a Gaussian model. Sine is low pass filter. Sine is a shift of a Gaussian model 90 degrees, so become high pass field. That's what we call wavelets, 小波。那一样 the same thing. So the basis function is a cosine and sine. So the same is here. If I collect all the data together here, so the object, the image is V1. Each image V1. The second image is V2. And until the final image is Vn. So I collect all the images together. And the coefficient is 1 because the image is plus together. Equal to, then if I use the transfer to the eigenspace, you'll find the result the same is the eigenvector 1. Eigenvector 1 is eigenface. What's eigenface? Eigenface look like this one. Eigenface. Sorry, eigenvector. So we have a eigenvector 1 to eigenvector n. I say again. So if your data has a 45 by 4, 你刚刚有45乘4个嘛，4个 object 嘛，每个 object 有45个张影像嘛，那这45乘4就这么多影像。你转到 eigenspace, your eigenvector has the same number. It's a 45 by 4 eigenvector here, and each eigenvector corresponding to eigenvalue. 就这个，它有这个特色哦。这那个什么物质不寐嘛，你有这么多 data 转到 eigenspace 还是这么多 data， 那能量不寐，那这是 eigen 的 vector 跟 eigenvalue。好，我重点在这里。This one, any image can reconstruct by linear combination of eigenvector times corresponding weight. After you have this, we call domain knowledge from original space transfer to eigenspace, your eigenvector, eigenvalue. And then any image is equal to linear combination of what? Eigenvector. For each eigenvector, for times corresponding weight, we call projection weight. 意思是说 你在转到 eigenspace 的时候，任何一张影像是线性组合，可以从这些 eigen 的这些东西组合回来。那意思重点就是说，这是 weight W1 W2 this weight we call projection weight。那你总共刚刚讲到，你总共有45乘4个 eigen 向量嘛 ，eigen weight 嘛，但是后面都不重要 ，because the good thing is that you don't need the rest of the small projection weight. You just need, suppose we have a 45 by 4 image. Probably you only need 5. The first 5 eigen vector you can reconstruct back to any of the image. That's meaning you only need the first 5 projection weight and represent this target. That's the idea of the eigenspace. 听得懂吗？我用中文再讲一下，你本来有这45乘5嘛，这45乘4嘛，那 eigen 是45乘4的 dimension， 所以你有45乘4张这个 eigen vector。那我给定你任何一张图，这个图，它基本上是可以组合回来，就从这45张乘上这个系数，组合成原来那一张叫 reconstruction。所以意思是说，每一张图它对应就是45个这个 projection weight。Any image just mean any image will can be represented by W1 to W45 times 4. However, most of the most of W is very small value. Doesn't matter. We don't care. So probably only the first five weight, projection weight is a big value. So that's meaning each image equal to the first 5 projection weights. 然后拿这5个来比较就好了。So when we do the comparison, anyone project to the eigenspace only pick up the first 5 projection weight, and we can do the comparison, and I can do the classification. Okay, so the same as what compression. 你说压缩也是一模一样哦。我把这个讲完，这一页讲。When you do what's compression? 压缩嘛。You use a zip file, zip file, IR file. 你怎么做压缩？很单纯，我有个 basic function 就是这个。So eigen will be my basic function. And when you do the comparison, and the computer just remember the weight, projection weight. And when I copy you compression, you send to me, and I try to recover the compression file. First of all, I need to have your eigen space. So I need to have a zip code. 我要你的解压缩的那个 folder 啊，你给我解压缩 decoder 或 download， 所以我们两个 decoder 的那个基本的我们的 basic function 都一样。那你只要系数给我，我就可以把它 reconstruct 回来原来的影像。所以这压缩也是一模一样的道理。我们做 compression 的道理是一样。所以 so when we want to see the video here, right? Want to see the video. First of all, you need to have a what? Decoder. 你要有解压缩器嘛 ，encoder decoder 嘛。So if we have a video player, we have the same player. That's meaning we have the same basis function. Like we have the same eigenface or eigenspace. And so you just send me the coefficients, the projection weight, and I can recover. So the compression can be very small. The file can be very small space. Second is for the comparison, suppose you want to recover all of them, then I need to use 45 times 4 projection weights. If I want to compress more, 我要压缩比较大一点。Suppose I only need only 5 dimension, and then I have use the semi only 5 dimension. So when I try to recover, I only based on the 5 projection weight, and the recover result it's okay, but there was some blurring. 就是我只要你说把那5个系数给我，我帮你就压缩很大，我本来是这么大的压缩，我现在只剩下5个维度，那我恢复回来的影像看起来还好，看得出来，就没有什么影响，但细节可能就不见了。所以压缩是这个意思，所以就 depend on 你要压缩比要多少，你压缩比较大，就压缩很多，那你的话，你这个系数就少一点，牺牲掉了。你希望保留更多 data， 你限给我这个系数就要多一点，那空间就大了。这样，所以 PCA 本身是做这件事情，原理一模一样。Okay, so we take a 10 minutes break. So right now is 07. So we'll next hour will be 10 17. 10 17. Okay. 10 17，就17分的时候再上课。